In this video, I'm going to do problem number 5 on the third quiz, and that problem is to do one of the book problems, number 17 in section 5.6. And I wanted you to show all your work because the answer is in the back of the book. It says that the vat shown in the accompanying figure contains water to a depth of 2 meters. Find the work required to pump all the water out the top of the vat. So I've tried to draw this the best that I can here, but this vat is not filled completely with water. It's just filled to a depth of 2 meters. Now I've drawn a little vertical axis here. We could think of this as the x-axis or t-axis, whatever you want to call it. And notice if this is 0 down here, this would be at a height of 2, and this is a height of 3. Okay, now how do we find how much work is required to pump all this water out the top of the tank? Well, we're just going to consider a thin little layer of water, and let's say this layer is at a height of x right here, and let's give it a little thickness to the layer. Okay, the layer extends all the way back this way, and the question is how much work, man, that's terrible. Let me try this again here. The question is how much work is required to lift this layer up to the top of the tank. Okay, now then eventually we'll talk about how do you find how much work is required to pump all of the water out the top of the tank, but let's just consider this one little layer. Now the work required, if we have a constant force, it's equal to force times distance, and actually we do have a constant force because the force that is going to be required is basically just the weight. Okay, it is just the weight of this little thin layer of water. Okay, so the work for this little layer of water is going to be force times distance. Now, the distance that this layer is going to have to travel, if this distance is x and this full distance is 3, then the distance this will have to travel is 3 minus x. Okay, so d is going to be 3 minus x. Now, what is the force? Well, it's just the weight. But to find the weight, what we need to know is what is the volume of that little layer of water, and then also how much does water weigh? Okay, what is the weight density of water? Okay, and we are given the weight density of water is 9,810 newtons per cubic meter. Now the hard part though is finding what is the volume. Okay, what is the volume of this little thin layer of water? Now if you look at the thin little layer of water, it's basically a box. Now it's not exactly a box because these are angled in just slightly here, but it can be approximated by the volume of a box. Okay, so what is the volume of this little thin layer of water? Well, every box has a length, a width, and a height. Now notice the height of this, okay, that little height there is just what we call delta x. Okay, the length of this is 6. Okay, so remember that this length here was 6. Okay, 6 meters. Now what is the width? This is the hardest part here. What is the width of this? Now I'm going to redraw this triangle right here. I'm going to redraw this big triangle here, right here. Okay, and notice that this is 2 meters. Why is it 2? Well, the top part was 4. Okay, if you go up and look at our picture here, the top part was 4, so this will be 2. And this length here is 3. Okay, now what if we're here at a height of x, right? So this height is x. What would this length be? Now notice what we have here are really 2 triangles. We have this big triangle and then we have this smaller triangle. And those triangles are really similar. Okay, I mean similar in a mathematical sense, geometric sense. They have the same angles. They both have a right angle here. Of course they both have the same angle down here. So therefore they both have the same angles here. Okay, now notice that this length is 2/3 of this length here. Okay, this length is 2/3 of this length. Okay, and so therefore this length should be 2/3 of this length. And if this length is x, this length should be 2/3 of x. Okay, now that's just that length. What we so that's this length here is 2/3 x. What we really want is this whole length here, which would be 2 times that. So what we have is 2 times 2/3 x, or 4/3 x. That's this length here. This is 2/3 x, and so this whole thing would be 4/3 x. Okay, so we use similar triangles. So if we go back up to this picture, we have 4/3 x times 6 times delta x. That this whole part here, that's the volume of our little layer of water. Okay, now if we want to find the uh, amount of work, so that's this whole amount here is the amount of work required to pump this layer up to the top of the tank, lift it to the top of the tank. If we want to find the work required to pump all the water out the top of the tank, we can think of this as just a whole bunch of thin little layers that we have to lift each of those layers up to the top of the tank and find the work required for each layer, add them all up, and that will give us the total work. Okay, or an approximation of the total work. To get the exact answer, we take the limit as the width of these things goes to 0, and what we end up with is an integral. Okay, so down here, our work, our total work, not just the work required to lift that one layer, the total work is going to be the integral. Now, from 0 to 2, we don't go from 0 to 3, because the water stops at a height of 2. Now where did the 3 come into play? The 3 comes into play over here with the 3 minus x. Okay, but we only have to integrate from 0 to 2. And the thing that we're going to integrate is this. We have 4/3 x times 6 times, well, the delta x becomes a dx on the end here. We have 9,810 times 3 minus x. Okay, now we can bring a lot of these terms out front. Okay, we get 4/3 times 6 times 9810 times the integral from 0 to 2 of x times 3 minus x dx. Okay, now 4/3 times 6, that'd be 24 over 3, which would be 8. So we have 8 times 9810 times the integral from 0 to 2 of 3x minus x squared over minus x squared, sorry, dx. Okay, now 9 times 9, or 8 times 9,810. I'm not going to work that out. I have to do that in my head here. Let's just what we have is 3x squared over 2 minus x cubed over 3 from 0 to 2. Okay, and if you work this out, you should end up getting 261,600 joules.